Okay, now today we'll learn a periodic function. If f of t is a periodic function with the period t, capital letter T, that is f of small letter t plus capital letter T is equal to f of t, then Laplace of f of t is equal to 1 divided by 1 minus e to the power of minus s into t into integral 0 to t, capital letter T, e to the power of minus st into f of t into dt. So this you should know. Whenever if they ask with the period t, capital letter T, then we have to apply this formula 1 divided by 1 minus e to the power of minus st into integral 0 to t e to the power of minus st f of t into dt. Okay. Now problem. Please read this statement of the problem carefully. Find the Laplace transform of the sawtoothed wave of period capital letter T given f of t is equal to t divided by t for 0 less than t less than capital letter T. So here you can notice first what is capital letter T. In this period capital letter T is t only. So f of t is given t divided by t. So making use of this, we write Laplace of f of t is equal to 1 divided by 1 minus e to the power of minus s into t only integral t is equal to 0 to t is equal to capital letter T only e to the power of minus s into t into small letter t divided by capital letter T into dt. Now what happens? You just remove that constant term outside. Which one? That is 1 by t, capital letter T. So what happens? We get 1 by t into 1 minus e to the power of minus s into t integral t is equal to 0 to capital letter T e to the power of minus s into t into dt. In the next step, 1 divided by t into 1 minus e to the power of minus s into t. Now we have to integrate this. Rearranging once again this one, what we will keep means t into e to the power of minus s into t. Using ILATE, integration by ILATE. That means ILATE, inverse logarithmic algebraic trigonometric exponential. So algebraic comes first, then exponential. So this you call it as u, this you call it as v dash. So by using Bernoulli's rule, integration, we get 1 divided by t into 1 minus e to the power of minus s into t. This is t, this is integration. So therefore t into e to the power of minus s into t divided by, with respect to t means a minus s in the denominator, then alternative sign minus, then differentiation of t is 1, integration of this one is e to the power of minus st divided by minus s into minus s whole square. The next one is plus differentiation of 1 is 0, so stop it. Then t is equal to 0 to t is equal to capital letter T. So this is by what means Bernoulli's rule. Now we have to simplify. 1 minus e to the power of minus s into t, this one. Now you people substitute the upper limits. In place of small letter t, you put capital letter T. Then what happens? Minus t into e to the power of minus s into t divided by s. This minus sign is there in the numerator. Minus, this is t. This is plus e to the power of minus s into t divided by s square. Then lower limit, this is upper limit, minus lower limit, t value is 0, 0 into something is 0, then minus e to the power of minus s into 0, that is nothing but 1, e to the power of minus s into 0 is 1 divided by this minus s whole square is s square only, this is 0, so stop it, close this. Now what happens, 1 divided by t into 1 minus e to the power of minus s into t, okay. Now what happens, this is minus t e to the power of minus s into t divided by s minus e to the power of minus st divided by s square plus 1 by s square. Now what happens, you take this common factor 1 by t into 1 minus e to the power of minus s into t, this one 1 minus e to the power of minus st, you club it, this and this, because LCM is same, s square, this and this, first positive term then negative term, then minus t into e to the power of minus s into t divided by s, okay. Then finally if you simplify this one, this and this get cancels, we get finally 1 divided by t into s square, further simplification, minus tt get cancels, this is minus e to the power of minus s into t divided by s into 1 minus e to the power of minus s into t. This is your solution. So answer is 1 divided by t into s square minus e to the power of minus st divided by s into 1 minus e to the power of minus st. Okay, next one we have to take, okay. So this problem, find the Laplace transform of the full wave rectifier f of t is equal to e sin wt or omega t, that depends on the people, okay, so how they read it, e sin wt or omega t, 0 less than t less than pi by omega, having period pi by omega. Now how to solve this one, f of t is given here, so when f of t is given, we have to start like this, Laplace of f of t is equal to, here one thing you people notice, a capital letter T is pi by w, that means omega, okay, pi by omega, so 1 divided by 1 minus e to the power of minus of s into pi by omega, integral t is equal to 0 to pi by omega, then e to the power of minus s into t into e sin the omega t into dt, this is, so please observe that. Now what happens, we arrange this in this way and we keep minus pi s divided by omega, okay. Then e is constant, keep it outside, integral t is equal to 0 to pi by omega e to the power of minus st into sin omega t dt, this is. You know one formula in 12th standard you people studied. So what is that means? Integral e to the power of ax sin bx dx. This is e to the power of ax divided by a square plus b square into a sin bx minus b cos bx. This formula you know, the derived formula. Using this, we have to simplify this. Here, you observe x is replaced by t, a is minus s. B is here omega, x is t. So A is minus s, B is omega. Okay, so x is nothing but here t. You people should know. Now substituting all this in this, so e divided by 1 minus e to the power minus pi s divided by omega into e to the power of so this e to the power of a value is minus s t divided by a square minus s whole square, that is s square, then omega square, then a minus s into sine omega t, then minus b omega cos omega t. Now what happens? We get e divided by 1 minus e to the power of minus pi s divided by omega into, this is t is equal to, here t is equal to 0 to pi by omega. This is substituting that in this. First we'll go for what means upper limit e to the power of minus pi s divided by omega divided by s square plus omega square. Upper limit only I am substituting. This pi by omega, if you substitute omega get cancels, pi, sin pi is 0. So first term is 0. 0 into minus s is minus 0, that is. Then minus omega into, this is pi by omega, cos pi is minus 1. This is upper limit minus lower limit. Lower limit is again nothing but e to the power of, this is 0 divided by s square plus omega square, then this is sin 0 is 0 minus cos 0 is 1. Now what happens? e divided by 1 minus e to the power of minus pi s divided by omega into, this is here LCM is, you can notice LCM is s square plus omega square. This is plus omega. So 0 plus omega is omega only. Omega into this. Then this is 1. Minus into minus is plus omega. So omega e to the power of minus pi s divided by omega plus omega divided by s square plus omega square. This is okay. So now omega common, keep it outside. So we get omega e divided by s square plus omega square, this one outside. In the denominator 1 minus e to the power minus pi s divided by omega. Then in the numerator, here omega taken outside means 1 plus this, 1 plus e to the power minus pi s divided by omega. But when you simplify this further, okay, we can write it when we multiply the numerator and denominator by e to the power of pi s divided by 2 omega, multiply and divided by e to the power of pi s divided by 2 omega. What happens to this? So omega e divided by s square plus omega square e to the power of pi s divided by 2 omega 1 plus e to the power minus pi s divided by omega divided by e to the power of pi s divided by 2w or 2 omega 1 minus e to the power minus pi s divided by omega. This is equal to, what will happen? You see, omega e divided by s square plus omega square When we multiply this, e to the power of pi s divided by 2 omega, then plus e to the power of minus pi s divided by 2 omega divided by e to the power of pi s divided by 2 omega minus this is e to the power of minus pi s divided by 2 omega. Now you know one formula. What is that means? Just I'll write here. Tan hx is equal to e to the power of x. Tan hx is e to the power of x minus e to the power minus x divided by e to the power of x plus e to the power of minus x. Here x is nothing but pi s divided by 2 omega. Now if you observe here, minus sign is there, this minus sign is there in the denominator, this plus is there in the numerator. Please observe all of you. Okay, so here tan hx is e to the power of x minus e to the power minus x divided by e to the power of x plus e to the power of minus x. So this we can write it as what means cot hx. Cot hx is what means e to the power of x plus e to the power of minus x divided by e to the power of x minus e to the power of minus x. So that is nothing but what means this. So we can write it this one as omega e divided by s square plus omega square cot hyperbolic pi s divided by 2 omega. This is your answer. Because of this tan hx, this we can assume it as cot hx, because cot hx formula is e to the power of x plus e to the power of minus x divided by e to the power of x minus e to the power of minus x. So here x is pi s by 2 omega or 2w. So this we can write it as finally omega e divided by s square plus omega square into cot hyperbolic pi s divided by 2 omega. This is the simplified answer. Why I am showing this one means in the exam they may ask you people show that or prove that the Laplace transform of f of t is equal to this. Then we have to follow this method. Otherwise you can stop at any stage. Okay, so either here or here like that. Okay, next problem. Next problem. Yeah. So here find the Laplace transform of the function f of t is equal to e sin omega t, where 0 less than t less than pi by omega. Another function is 0 for pi by omega less than t less than 2 pi by omega. Now how to solve this? How to solve this one? So this is a discontinuous function. Now in this Laplace of f of t is equal to, here you can notice a capital letter T is 2 pi by omega. So 1 divided by 1 minus e to the power of minus s into 2 pi by omega integral t is equal to 0 to 2 pi by omega e to the power of minus s into t into f of t into dt. So observe 0 to 2 pi by omega e to the power of minus s t f of t into dt. Okay, now because of this discontinuous function 0 to pi by omega to 2 pi by omega, we have to split this. 1 minus e to the power of minus 2 pi s divided by omega. Okay, then integral t is equal to 0 to pi by omega according to this e to the power of minus s into t into e sin omega t into dt plus t is equal to pi by omega to t is equal to 2 pi by omega. Then e to the power of minus s into t into this is 0 into dt. Okay, this is. Now we have to do simplification. This is 0 into something is 0 only, gone. This is okay, vanished. Now only this integral will be there. This constant you keep it outside. E divided by 1 minus e to the power of minus 2 pi s divided by omega. Okay, 1 e divided by 1 minus e to the power of minus 2 pi s divided by omega. Integral t is equal to 0 to pi by omega e to the power of minus s into t sine okay omega t into dt. This is anyway 0. This is. Now what happens, we have to simplify this. We have to simplify this one. Now how to simplify this? E divided by 1 minus e to the power of minus 2 pi s divided by omega into e to the power of minus s into, this is like earlier in the previous problem we used that formula e to the power of ax sine bx. So e to the power of minus st divided by s square minus s whole square, that is s square only, plus omega square is omega square, then minus s into sine omega t, then minus omega into cos omega t. Okay, this is. Then t is equal to 0 to pi by omega. Now simplify this. Okay, so simplify this one. So e divided by 1 minus e to the power of minus 2 pi s divided by omega, then upper limit e to the power of minus pi s divided by w divided by s square plus w square. Okay, then again w get cancelled, sin pi is 0, minus 0 into something is 0 only, minus w into cos pi is minus 1. This is. Then again next is upper limit minus lower limit is 1 divided by s square plus omega square. Okay, then again this is sin 0 is 0 minus cos 0 is 1 w. So this we have to write it like this. Now e into, this is w, this is minus minus plus w, LCM is same, so therefore this is omega e to the power of minus pi s divided by w plus w divided by this into this s square plus omega square into 1 minus e to the power of minus 2 pi s divided by w. This is. Now what happens, we have to split this. Here take out the common factor. W is common. Okay, w is common. E into 1 plus e to the power of minus pi s divided by w. Whole thing is divided by s square plus w square. You split this one. It is just like e to 1 square minus e to the power of minus pi s divided by w whole square, like that. So what happens, we 1 plus e to the power of minus pi s by w divided by s square plus w square into, this is a square minus b square formula, a plus b into a minus b, 1 plus e to the power of minus pi s by w into 1 minus e to the power minus pi s divided by w. This is this and this get cancels. We get finally omega e divided by s square plus omega square, okay, into 1 minus e to the power of minus pi s by w. This is your answer. Okay, this is your answer. So the next one. Next one is find the Laplace transform of the square wave or meander function of period a defined as f of t is equal to k where 0 less than t less than a for minus k a less than t less than 2a. Now sir, how to do this? It's very simple. Okay, so we have to simplify this I'll show you here. Laplace of f of t is equal to, here you notice t is equal to 2a, t is equal to 2a, so 1 divided by 1 minus e to the power of minus s into 2a, okay, integral 0 to 2a e to the power of minus st into f of t into dt. This is now the same thing we can write like this, 1 minus e to the power of minus 2as, okay. Then start splitting this discontinuous functions. T is equal to 0 to a e to the power of minus st, okay. Then f of t is k into dt, then a to 2a e to the power of minus st into minus k into dt, okay. Then next step, what happens? Anyway, from both k is common, take it outside. K 1 minus e to the power of minus 2as, okay. Then integral t is equal to 0 to a e to the power of minus st into dt. This minus sign, integral t is equal to a to 2a e to the power of minus st into dt. This is now what happens, we have to simplify this. K divided by 1 minus e to the power of minus 2as into e to the power of minus st integration is e to the power of minus st divided by minus s. Apply the limits 0 to a minus e to the power of minus st divided by minus s. Apply the limits a to 2a, okay. Now what happens? We get substituting the limits 1 minus e to the power of, this is, we can write it as 1 square minus e to the power of minus as whole square. This 1 minus 2 minus 2as, so we can write it as like this, okay. Then you simplify this, e to the power of minus as divided by minus s. Then 0 means the lower limit is minus minus plus 1 divided by s. This is our upper limit, okay. Upper limit is this. Then upper limit for this one is minus minus plus plus e to the power of minus 2as divided by s. Then minus of minus is plus, plus into minus is minus e to the power of minus as divided by s. So this is lower limit, okay. Now what is the next procedure? So which one get cancels here means nothing will get cancelled here, so we have to keep like this, 1 plus e to the power of minus as into 1 minus e to the power of minus as in the denominator here. In the numerator here, this is LCM is s only, okay, and this is 1 is there here, then this and this, okay. So minus 2 times of e to the power of minus as plus e to the power of minus 2as. So this is, now what happens, we can write it as okay, k into 1 minus e to the power of minus as whole square divided by 1 plus e to the power of minus as into 1 minus e to the power of minus as. One term get cancelled, so we get k into 1 minus e to the power of minus as divided by 1 plus e to the power of as. Okay, so this yes, forgot to mention, this is here, yes. Then what happens, if you observe this one, no, just like in the earlier problems we did the method multiplied and divided by e to the power of as by 2 into 1 minus e to the power of minus as divided by s into e to the power of as by 2 into 1 plus e to the power of minus as. We get this as k into e to the power of as by 2, this one, minus this into this e to the power of minus as by 2 divided by s into e to the power of as by 2 plus e to the power of minus as by 2. This is equal to k by s. You just learnt in the earlier the tan hyperbolic of as by 2. Tan hyperbolic of as by 2. This is your answer. Okay, so k by s into tan hyperbolic as by 2. Please observe here one thing I want to tell you people. How do you know that when it is divided by 2 means? One hint I will give you people. Whenever if you see like this 1 minus e to the power of minus as divided by 1 plus e to the power of minus as, or otherwise 1 minus e to the power of as by 2, 1 plus e to the power of minus as by 2, that type of problems means anytime. Okay, so you just multiply the numerator and denominator by e to the power of this whatever the value excluding the signs, whatever the value you will get now, that divided by 2. You any problem you see, even we did one more problem in the earlier case, there also we did like that only. So e to the power of pi s divided by 2 omega, like that. So here also divided by 2, you see that you multiply, then you will get the answer always. So this is the easiest method. Okay, try to remember this always. Okay, this step. Okay, why means most of the times they will ask like this only, find like that. Okay, so then you can stop at any stage. If they ask prove that, show that Laplace transform of this function, okay, so to this is equal to k by s into tan hyperbolic as by 2 means, then you have to proceed up to here. Okay, so please learn with interest. Okay, read. Okay, so learn each step thoroughly. Okay, learn. Okay, so you should know your earlier classes problems and methods and the formula. Okay, then only you can understand this. Thank you.